The suspension system in a car serves multiple crucial roles. It provides a smooth ride over uneven surfaces, maintains tire contact with the road, and contributes to handling and vehicle stability. By managing the forces between the road and the car's body, it ensures comfort for the occupants and optimal vehicle performance. Here's how a car suspension system works. Basic components. Springs. These absorb and store energy. Springs can be of different types, such as coil springs, most common for passenger cars, leaf springs, often found on trucks, or torsion bars. Shock absorbers, or dampers. These dissipate the energy absorbed by springs, preventing the car from bouncing continuously after hitting a bump. They convert kinetic energy into thermal energy, which is then dissipated into the atmosphere. Struts. A strut combines the function of a shock absorber and a spring in a single unit. Many modern cars utilize strut-based suspension designs, such as the popular McPherson strut. Anti-roll bars, or sway bars. These are used to prevent excessive body roll during cornering. They connect the left and right sides of the suspension and ensure they move in tandem, offering increased stability. Control arms and bushings. These components provide the mounting points for the suspension and determine the motion path of the wheels. Ball joints. These are pivot points that allow for movement in multiple directions, accommodating both the steering mechanism and the suspension's movement. Operation. Absorbing bumps. When the wheel encounters a bump, it moves upward. The spring compresses, absorbing the energy. As the wheel moves down into a depression, the spring extends. This stored energy in the spring needs to be managed to prevent the vehicle from bouncing uncontrollably. Damping oscillations. After the spring compresses and releases, it can cause multiple oscillations. The shock absorber or damper controls these oscillations. Inside a shock absorber, there's a piston moving within an oil-filled chamber. As the piston moves, it forces oil through small openings, creating resistance which dampens the oscillations. Handling and cornering. During cornering, the car's body tends to roll, or lean, towards the outside of the turn. Anti-roll bars help mitigate this. When one side of the suspension compresses, the side on the outside of the turn, the anti-roll bar transfers some of that compression force to the other side, inside of the turn, reducing body roll and aiding in stable cornering. Isolating road noise and vibrations. The bushings, often made of rubber or polyurethane, help in isolating the vehicle's body from road noise, vibrations, and minor shocks. Types of suspension systems. Independent suspension. Each wheel can move independently of the others. This design offers better handling and comfort. Common types include McPherson struts and double wishbone suspension. Dependent suspension. The movement of one wheel directly affects the opposite wheel. This is often found in older vehicles or heavy-duty applications. Leaf spring suspensions on some trucks are an example. Active and semi-active suspension. These are advanced systems that can adjust themselves in real time based on road conditions and driving demands. They use sensors and electronic controls to optimize ride and handling dynamically. In summary, the suspension system in a car is a combination of various components working together to manage the forces between the vehicle and the road. The primary goals are to provide comfort, maintain tire contact with the road, and ensure stable handling.